All right, so next what we'll do is we have all the atoms, masses. We need to understand that sometimes we have atoms that exist in nature alone, like a noble gas, argon, neon, just sits there alone as a monatomic atom. Metals do this as well, and they can just exist as a single atom. And those elements that's stable enough on its own are called monatomic. They are so rare because they're mostly noble gases. But we do also have diatomic, and you might remember those from when we did our periodic table. Thanks, Mia. And these outlined in pink are the diatomics, and don't forget about 7 up as a way to remember them, including hydrogen. They exist as nature as a diatom, and that means 2 elements of the same, it's 2 atoms of the same element bonded together. So what would the mass of one molecule of oxygen be? Well, oxygen is typically O2, and I say that because there's different versions of oxygen, but oxygen gas we refer to as O2. The subscript says there's 2 of them. That means what we need to do is take 1 atom of oxygen and find its mass, which is 15.9949994, and then double that, and that would get to be 2 times that number is 31.9988, I believe. All right, and so that's how we calculate the simplest atom's atomic mass and add the atoms. So 2 oxygens weigh that much. Now we'll get into the compound. So when 2 atoms of a different element are bonded, we get a compound. And the first thing we'll do is calculate the formula mass in AMU, which means if each one has an atomic mass, we just weigh them, we just add them up. So this is called formula mass. All of this is called adding atoms, and it's a skill that we're practicing today for the first time, and we'll probably do every day for this unit. So when we take a formula mass of a hydrogen atom, for just 1 hydrogen atom, you take a look on the periodic table again. We look up there. We see that is 1.00794 AMU. And that's what we measure formula masses in. Then we have a different kind of measurement, and that's called the gram formula mass. It's when we just assume, basically change AMUs to grams for bookkeeping purposes. Gram formula mass, and GFM is what we refer to it, the GFM, and that's the same thing. So it's the mass of 1 mole of an atom or molecule and so forth. And that brings up, what the heck is a mole? Well, we'll talk much more about it, but let me just get to the easy part, which is how do you find the gram for the mass of hydrogen? Well, surprise, surprise, it's 1.00794 grams. That's what the gram formula mass is, and that's how many grams there are in 1 mole of a hydrogen atom is. Now this is 1 atom, so the gram formula mass of hydrogen is this. This is the mass of 1 mole of hydrogen, but it's just atomic hydrogen, so keep that in mind. This brings up what I mentioned before, which is the mole. And what does a mole look like? Well, this is what a mole of aluminum looks like, and this is what a mole of copper looks like. Okay, these are 1 mole of something, and I'll get into what we can think about in just a second. But 1 mole of something, for example, of carbon, 1 mole of carbon is going to be 12.011. Oh my gosh, sorry, my bad. 1 mole of carbon is this many grams, but I meant to write it here, 12.011 grams of carbon. But how many atoms of that is? Well, this is where they all even out. So you can have atoms, if you can have the same number of atoms they'll have a different mass because atoms weigh a different amount, and that makes sense. It's like putting eggs in a dozen egg basket or putting lead bricks, and you could have the same number of lead in lead eggs and regular eggs, but the lead eggs will weigh tremendously more. So we have to create the number, like if we said a dozen, there's 12 of something. Moles is a lot larger number, and it comes back to the fact that there's so many atoms in a substance. And it's 6.022 times 10 to the 23rd atoms. And that's what a mole of a substance is. All right, we'll get to calculations with that in a little bit. We're going to keep it simpler by just calculating the gram formula mass and formula masses of substances and learn how to add atoms. All right, so more on moles later. What is the formula mass for potassium carbonate? So for this, you want to break down all the atoms into their individual, or the molecule in an individual part. We have potassium, we have carbon, we have oxygen. And this data keeping table will help us keep track of everything. We look up how many we have in our formula, knowing that the subscripts and parentheses can help make it a little harder, but it's not too hard. There's 2 potassiums, and each one of them will weigh a certain amount. And we have 1 carbon, that will weigh a certain amount. And then we have 3 oxygens, and that will weigh, of course, a certain amount. Then we're going to add those up together to get our complete formula mass, which will be in grams. All right, so let's take a look at the potassiums. There's 2 of them, and each of them weigh 39.0. If you forget where I got this number, just rewind a bit to the beginning. That's right from the upper left of the periodic table for each element. We have carbon, which is 12.011, and we have oxygen, which is 15.9994. And then we multiply them by how many we have of each, so we have a total of 78.1966 grams per mole of potassium. We have 11 grams of carbon in this molecule for 1 mole of molecule, and we have 47.9982 of oxygen. And then we'll add those up, and I'll do this first one with you, pretty nice and steady. Get my moles of atoms everywhere floating around. We're just going to take those numbers and add them up, and I think you got how I got them. Let me just, maybe this will help. If I have both of those on the screen at the same time. All right, so let's take a look at it. We're going to have 78. Let me just make sure I can get this to work. 78.1966. And then we'll add 12.011. Nope. Yeah, there's just 1 carbon. Sorry. Yep. Plus 47.9982. So I get a gram formula mass of 138.2058. You know, check my math, make sure, check your math. This is where a little error could come in place anywhere, and you might not know where it came from. So that's all. All right, let's do another one. We have, what is a gram formula mass of copper sulfate 5-hydrate? So this pentahydrate thing, this idea of having multiple waters, well, just means you have a salt, and you have a specific ratio of waters to salt. So this means we have 5 waters. And when they get this complicated, which is about as complicated as they get, what I want you to do is, here, let me go back to my main screen. So at least it might take up more of the screen, and you can see. We'll do what we did before, but I'm going to do first for the copper sulfate, then I'm going to do for water, and then I'm going to multiply by 5, So I'm going to find these values. I'm going to find the mass of water. I'm going to find the mass of copper sulfate. And then I'm going to add copper sulfate's mass to the 5 waters. So let's break it down. We have 3 elements. We have copper, sulfur, and oxygen. And we have 1 copper, we have 1 sulfur, and we have 4 oxygens. So we multiply this by 1, and the mass of copper is 63.546, and the mass of sulfur is 32.065, I believe, and the mass of oxygen is 15.994. Now, this is where it gets really exciting. Yes, yes. We're going to add those up. So we have 63.546 plus 32.065 plus 4 times 15.9994 is 63.976. And then adding up all of this gives me a formula mass of 159.587 grams. Okay, and that's grams per mole. We'll call it grams for formula mass. And then for water, I'm going to find 1 water. And do you agree if I have 5 of them, I can multiply by 5 later? That's what I would recommend doing. But in water, we're going to calculate with hydrogen. There's 2 hydrogens. And each one weighs you might remember, 1.00794. And in oxygen and water, there's just 1, and it's 15. And I'm hoping some of these numbers become repetitive enough, you can calculate it. Now, you'll just go over into your calculator and multiply 2. Let me make sure I'm on the right page here. 2. Oh, it's not working. All right. I have to do the buttons. 2. Whoa. I think I see what's happening. Let me just close this off. I think my buttons. Two times 1. Seven, 9, 4. Oh, sorry. That took way too long. So that's 2.01588. And then plus the 15.99. We get a number that you'll get a lot in these calculations. That's the mass of water, 12.01528. That's how many grams are in 1 mole of water. The reason that's important is we're going to keep coming back to that. For water, it's just a very common compound that we need the mass of, and then we'll need to take that and then multiply by 5. And how much water mass do we have in this compound? 90.0764. And then we'll need to multiply those two. Oh, I already got that, sorry. And when we add these together, we'll get a total compound mass of 249.6634 grams. And that is the mass of the entire copper sulfate hydrate, we call it, because it has water in it. That also concludes our notes for today. We're going to practice in the practice packet some problems, and I'm going to outline those problems so you can do some of them, but not too many of them. And if you look in your Google Classroom, you'll see which problems you're doing. But over here, you didn't calculate the gram form of the mass, so you'll take two bromines, add them together, that's our gram form of the mass. When they get a little more complicated, you might want to take it out and do the bookkeeping like I did. Aluminum times 1, chlorine times 3, and so forth. These can be tricky here. Just keep in mind that we have one lead, we have many different carbons, we have oxygens, and we have hydrogens. Now let me just read this formula with you because this is a common mistake. There's 2 of everything inside of here. So if there's a carbon, we know there's 2 of them. So let me just remind you, there's 1 lead in this one. There's 2 carbons times 2. So in reality, there's 4 carbons times how much each carbon weighs, as you know, 0.011. And then oxygen, how many are there? Well, there's 2 oxygens times 2, so there's 4 oxygens. Then how many hydrogens? Well, there's 3 here, but there's 2 total times that, so there's 6 hydrogens. All right, so that's an example. And then you have page 3 and a couple of those. If you have any questions, let me know. Everything is there. You won't have to do all of page 2 and 3, but you will have problems on page 2 and 3. If you want to do extra credit and do all of them, that's great. That concludes the notes.